Thanks, Carl and Cece. As demonstrated by the BetterReads iOS and web teams, one of the key features of BetterReads is to recommend new books to its users based on their prior reading history. So you've seen how it looks on the front end, but how does it work on the back end? When we were first onboarded to the BetterReads project, the data science team had inherited a mess of a code base, unnecessary feature branches, unlabeled pull requests, and unorganized GitHub repo structure. After investing a few days collecting our bearings and tidying things up, we learned that the prior data science team had a recommendation model, but nothing was deployed. Therefore, although we had a blank slate, at least we knew the general direction of where we wanted to go. So we planned out our steps in Notion to orient our team. We decided to embrace the opportunity to work with Docker and with three of Amazon Web Services' most popular microservices: Relational Database Service, or RDS, for hosting all of our book data, Route 53 for maintaining our web apps domain names, and Elastic Beanstalk for hosting our deployed backend recommendation APIs. And it was on Elastic Beanstalk where we deployed the recommendation model that the previous team had created, but they had not yet successfully deployed to a production environment. It's a collaborative filtering model that provides recommendations to the users based on the likes and dislikes of other users who are similar to them, which is largely how many social media sites and online shopping retailers make recommendations to their users. However, although this method provides excellent recommendations, it only received a 15% approval rating because the size of our dataset was so limited. If the user wanted to receive recommendations for a book that was not in our user ratings dataset from Kaggle, then they were left with dummy default recommendations. So we scraped data from hundreds of thousands of books from the Google Books API and used natural language processing to create an entirely new model that's based on book descriptions. We deployed both the first model and the second model because although this second model doesn't quite provide as accurate of recommendations as the first model, it does serve as an excellent fallback for when the user's book is not in the original dataset. This duo approach heightened our overall approval rating from 15% to 45%, resulting in a user experience that's 3 times greater than what the first model had provided. For our team's most recent model iteration during this project's timeline, we created a cosine similarity hybrid model, such as that of the world's great recommendation giants, such as Netflix and YouTube. So where did these approval values originate? The deep, dark world of tedious, manual, and time-consuming surveys. Although this process resulted in a surprising number of ultra-valuable insights into how we can improve our recommendation engine, we came to recently realize that there's a better way to automate the surveying process, while simultaneously increasing the size of our user ratings database. Coming soon to an internet near you, BetterReads, Tinder for books. Labs 25, it's up to you to make it happen. Make us proud.
Wow, congratulations. Working with all three different stacks, all three different functions, what were some of the hurdles that y'all had to overcome, and how did these teams bond together to overcome those hurdles?
From the data science perspective, I thought it was really an interesting fact to learn that our users were not just the readers, but our users are also the web developers and the iOS developers. So we had to serve them in a way and just communicate greatly in determining what format they wanted their data in.